Hello, this is Mr. Collier, and today we're graphing quadratics using tables, and then we're going to use the graphic display calculator. So in the first example here, we just got y equals x squared. This is the most basic quadratic equation we can get. And we're going to fill in a table of values and plot the points and see what we get. So I usually start with 0 because it's pretty easy. So in this case, we're going to have y equals 0 squared, which is just 0. For positive 1, we'll have y equals 1 squared, which is 1, and y equals 2 squared, which equals 4, and so forth. And because 1 squared is 1, and negative 1 squared is also 1, we get this symmetry. So when we have negative 2 squared, we get 4, and this one's also going to be a positive 9. So we get the same points here, above 0 and below 0. And we're going to have some symmetry in the graph as well. So I'm going to plot these points, 0, 0, 1, 1, and then we've got 2, 4, and 3, 9 doesn't fit on the graph, so I'll just leave that out. And we'll have the same points to the left of the graph, same y values, so we have symmetry in the graph. So it's not a straight line graph. Okay, it's quadratic, it's non-linear, so we have to draw a curve to fit this. Okay, now try not to make a sharp point. It should be a nice curve like that. So that's not too bad. Let's take a look at the GDC version to see what it looks like with a bit of a more perfect graph than this. Okay, so first to graph things, you need to press the y equals button here in the top left hand corner, and if you have something in here already, press clear. If one of your plots is on, like for example, if plot 1 is highlighted, you will need to go and press enter on it so that doesn't plot some statistical graph. Okay, so all this should be blank, and all the plot 1, plot 2, plot 3 should be not highlighted. And we just type in the equation of our function right here. Y equals x squared. And now I'm going to press graph, but I can't see anything because my scale is all messed up. So for this case, we want to go from 5, or maybe from negative 10 to 10. If you press zoom, and there's all kinds of zoom options, but zoom standard means from negative 10 to 10. So negative 10 to 10 on the x-axis, negative 10 to 10 on the y-axis. So I'm going to do zoom 6. And I should be able to see the graph. There's the graph there. So you see it's a lot smoother than the one I drew by hand. So that's what the graph of y equals x squared looks like. Let's look at another one. Okay, so we have y equals x squared minus 4. And I'm going to start with 0 again. So this is y equals 0 squared minus 4, which is negative 4. Y equals 1 squared minus 4, which is 1 minus 3, negative 3, and then we have 2 squared minus 4 is 4 minus 4 is 0, and then 3 squared minus 4 is 9 minus 4, which is 5. Okay, and then here we're going to get negative 1 squared minus 4, which is negative 3, and at this point we're going to see some symmetry again. Okay, here we get the 0. So can you guess what the next number is going to be? Okay, it's also going to be 5. Okay, so let's take a look at the graph. Okay, we have that point 0, negative 4, negative 1, negative 3, or sorry, 1, negative 3, 2, 0, and 3, 5. Okay, we got symmetry, so we'll have the same y values over here on the left. Okay, so we have another curve. I'm going to draw that again. You could make arrows at the end to indicate it goes on forever. Okay, that's the x-axis, the y-axis. So we've got the symmetry like I was talking about before. And we have a y-intercept. Yeah, we have a y-intercept. The y-intercept's right there. It's 0, negative 4. So lines have y-intercepts. Also, the curves have y-intercepts. And we have two x-intercepts in this case. We have 2, 0, and negative 2, 0. Okay, remember in the first example we had one x-intercept. In this case we have 2. And sometimes you can have none if the parabola is like over here or something. By the way, the shape is called a parabola shape. Okay? This is a parabola. Identify the vertex. Well, the vertex is just the, I guess you can call it the corner point, or this point right here. Okay? So that's the vertex. Okay, the vertex in this case is, well, the same as the y-intercept, which is not always the case. Alright, okay, next example. Okay, we have this function right here. Alright, let's start with 0 again. So we have y equals negative 2 times 0 squared plus 2, and that is just 2. Y equals negative 2 times 1 squared plus 2. Now this is going to give me negative 2 plus 2 is 0, and so forth. So we're going to work those out. This gives me 4. Remember to do the exponent first. So this gives me 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6. And the last one is probably going to be too small to go on our graph. We're going to get 9, then negative 18, so we're going to get negative 16. Here we're going to get y equals, let's see, negative 2 times negative 1 squared plus 2. Now because negative 1 and positive 1, when you square them, you get the same thing. These should be the same answer. So this should always also get me 0. And the symmetry will continue, and we'll get these points. Okay? So we have 0, 2, negative 1, 0. We have 1, 0, and 2, negative 6. Negative 2, negative 6. And this time we have an upside down parabola. It's pointing downwards, right? It's opening downwards. Why would that be the case? Well, it's actually because of this negative symbol here. It makes it an upside down parabola. So the y-intercept in this case is 0, 2. X-intercepts, there's 2 of them. Negative 1, 0, and 1, 0. The vertex is 0, 2. Okay, let's show that on the GDC. So I'm going to graph here, clear that, type in negative. Now not this negative, we got to do this one. That's for subtracting. This one's a negative symbol. 2x squared plus 2, hit graph. And we see this matches what we just did by hand. Okay, the next example. Okay, we've got this quadratic here, a little bit more complicated. We got an x term in here this time. So let's start off with the easy one, which is y equals 0 squared minus 2 times 0 plus, minus, I'll put a negative 15 there, okay. So that's all 0, and then we'll get a negative 15, of course. Okay, do I have negative 15 here? Yep. So that's my y-intercept. Okay, that's positive, so I think it's going to be pointing up, but let's get some more points. Y equals 1 squared minus 2 times 1 minus 15. So that'll give us 1 minus 2 is negative 1 minus 15 is negative 16. And next one, y equals 2 squared minus 2 times 2 minus 15. We get 4 minus 4 is 0. We're going to get negative 15 again. Okay, so it looks like we might get some symmetry again. And let's do the next one. 3 squared minus 2 times 3 minus 15. Okay, that'll give us 9 minus 6, which equals 3. 3 minus 15 equals negative 12. Okay, let's see if we get a negative 12 up here. We'll get 1 squared. Oh, sorry, this is negative 1 squared. Minus 2 times negative 1 minus 15. So we're going to get 1 plus 2 is 3. 3 minus 15 is negative 12. Y equals negative 2 squared minus 2 times negative 2 minus 15. That equals 4 plus 4 is 8. 8 minus 15 gives us negative 7. And lastly, we got negative 3 squared minus 2 times negative 3 minus 15. We'll get 9 plus 6 is 15. 15 minus 15 gives us 0. Okay, so let's graph those points now. We have, let's start with this one, negative 3, 0. So that's an x-intercept. -2, -7, -1, -12. We have 0, yeah, we have 0, -15 already there. 1, -16. Then we've got 2, -15. So it looks like, okay, we got one more, 3, -12. It looks like this is the vertex, and remember the parabola is symmetric. So even though we don't have any more of this table, we can use the symmetry of the graph to plot the other points. Okay, so I can plot that point, and I know that the other x-intercept is going to be right over here. Okay, so we don't need to do all the calculations. We can use the symmetry of the graph to find some things. So the vertex is right there. It's 1, -16. So 1, -16. The y-intercept is 0, -15. The x-intercepts are -3, 0, and -5, sorry, +5, 0. And we can try to draw a nice curve through there. Maybe extend it a bit and draw some arrows.